All right. Hello, everyone, and welcome to a very special edition of Space News, these live forums we've been doing. Typically, we do a wide panel, but today is very different. Today, we do just one very special guest. He is the president, CEO, and co-founder of Intuitive Machines. Now, if you remember, Intuitive Machines is the very company that did the only commercial lunar landing back in February. This was the first U.S. craft to land on the moon since 1972. And they've been up to quite a bit since then. So we're going to get into a lot of that today. But first, I want to say thank you to our sponsor, Advanced Space. All right, let's get right to it. Steve, thanks so much for joining us here. I think the last time I saw you was just outside Mission Control when Odie touched down on the moon down in when we were down in Houston, and I saw you emerge from there, and you've been pretty busy since. I was hoping you can just kind of give us a little bit of an update, what you've been up to for the last couple months. But before you do that, point us in the direction of where you're going next. I'm talking about this next lunar mission, IM-2. Give us some updates, explain to us, to people who are not as quite familiar with this, what the broader mission is and where you see this really heading.
Hey, hello, David. I appreciate you having me on today. Yeah, and welcome everybody who's tuned in for this hour. So, pleasure to talk to you. It's been quite an exciting year, 2024, for Intuitive Machines. You mentioned our landing on the moon in February, which was absolutely an epic accomplishment. We're moving forward, looking to IM2 in the first quarter of 2025. We're going to have a much more complicated mission for IM2. You know, the first mission was a demonstration that you could land softly on the moon. Well, for this second mission, we're actually flying a number of technologies that will enable surface prospecting for water ice in the future. So we'll take a Prime 1 drill, which is the Trident drill and mass spectrometer, to drill a meter down into the surface of the moon and exercise, that drill to see if it can function as a complex mechanism. It's actually deployed from the side of the lander and then drills in 10 centimeter increments down to a meter deep. And then the mass spectrometer looks at the tailings pile that comes out of the hole and looks for water vapor. Whether we actually find water vapor or not is not what we're looking for. We're looking to test the technology to drill into the lunar surface. The other one that I find fascinating is an invention by Intuitive Machines called the Hopper. And it's a spacecraft that hops off the side of the lander and then can hop in several different ways. It hops across the lunar surface and then down into a permanently shadowed region of the moon with a neutron spectrometer at the base of it that looks for water ice in the permanently shadowed crater. And then there's another one that's a rover that roves away from the lander and tests a surface communication cellular technology with Nokia Space. And then the other thing people don't know is we're flying a rideshare payload with Jet Propulsion Laboratories called the Lunar Trailblazer, which is a hyperspectral imager that will take a close-up look at the South Pole from orbit and see where the greatest concentration of water might exist on the moon. So quite a fascinating mission. We're going to land closer to the South Pole than we did last time. Last time was kind of like on the continent of Antarctica equivalent. And now we'll be considerably closer, maybe about 15 kilometers from the South Pole itself.
I wanted to talk about that specifically because I think when you, to the layman audience, you might hear sort of landing on the moon. It's like, okay, the United States did that back in 1972, and then you've had all these subsequent missions, certainly the India a lander, and it's just different in terms of the region that you're looking at, in terms of topography, in terms of climate, in terms of just sort of the sheer range of temperatures that you have to deal with. Um, but this does seem now that we're getting to this second mission, that this is ostensibly, in terms of what I think you hope to be the beginnings of real infrastructure capacity building in terms of that southern hemisphere of the moon. I wonder if you can kind of speak to that sort of more generally in terms of where you see that sort of transitioning and some of the technical challenges of just operating in that region.
Yeah, I think certainly you'll see the complication of the missions increase as we try to gain more scientific understanding of the South Pole region. We do know the South Pole region of the moon is the location with the greatest concentration of water ice and in the regolith, and we think that that's where human research will be centered via the NASA's Artemis program. And so by building an infrastructure or building a capability to deliver systems to that South Pole region, to get familiar with the um, topology of the moon in that area, the challenges with communicating from that area back to Earth, the environment of shadowed regions and sunlit regions with low sunlight angles and limited Earth viewing periods, all of those constraints have to be fit together in an operation.
Yeah.
And learning about that, we get greater and greater understanding so that we can actually create like a logistics supply kind of cadence of missions to deliver things to the moon, bring up heavier and heavier cargo to the moon, then communicate from the surface to our ground network and from our surface to our data relay planned data relay network, and then really to get to a position where you can push infrastructure first and operate it autonomously without the crew present. And then
Right.
when the crew finally arrives, we have quite the capability already at the moon and our understanding of the moon so that we can make it safer and also more productive for the crew when they do arrive.
You talk about the presence of water ice, suspected presence of water ice, that we pretty much have a clear indication that is there. And I think for most people, they might think, consumption or something to that for effect. But, through electrolysis, we're talking about fuel, we're talking about potential air, we're just a whole host of things that comes out of that. And so I guess the question that I would have then orients more around, you look at this massive structure in the sky and you think, okay, there's a lot of room there, but really the real estate is very specific in terms of where human beings can operate and where infrastructure development can take hold in a meaningful, viable, sustainable way. Is that fair? I would say, and how does that competition play in if that's the case?
Yeah, I think if you think about space exploration, and we need to learn to live and work off planet, and the moon gives us a great opportunity to look at locating resources that would be helpful to generate propellants for ascent vehicles, generate breathing air and oxygen, generate water, consumables for astronauts, and harvest from the environment things
Yeah.
that you don't have to bring with you in the future. And think about when you go further and further out towards Mars or out to Europa and those places. If you ever think of humans there, you can't afford to carry everything with you. You've got to be able to harvest from the location that you're at. And
Yeah.
so the moon is a great stepping stone to teach us about that. And that's why I think we're following the water and then learning all of these how to build these engineered systems that will uh, use the resource in situ. They call it in situ resource utilization to reactors that take and crack the regolith and extract the oxygen and hydrogen out of the water from the regolith. Those kinds of systems is what I think Intuitive Machines is trying to enable. We won't necessarily build those machines for um, making propellants and oxygen and water out of the regolith or extracting it, but we will provide the delivery, the communications, the navigation, and the autonomous ability to operate those machines autonomously. And if we can provide those utilities or those services, that's where we're going. And just getting a jump start on that with mission one and mission two, and then repeat that on a regular cadence will really keep the learning curve steep for us explorers that want to explore the moon.
How is IM2 different than IM1? I'm not talking necessarily about payloads, but like there are some clear lessons learned from that first mission.
Oh
What
yeah, you were
help us like
there.
what? Yeah.
You were there, living and breathing some of the challenges that we had for that mission. One of the big things that we want to get right is, refining our ground network so that we get great measurements for our position in space as we approach the moon for lunar orbit insertion. We want to be right where we need to be and understand where we want to be. And building a brand new ground network to do our first mission had its challenges, and all the kinks in that ground network were not completely worked out, and so the measurement quality for orbit determination um, was kind of scattered and not as the quality we wanted. So we've done a lot of work to improve our ground network so we can get an a pre-orbit position with accuracy, so that when we do our lunar orbit insertion burn, we know exactly precisely where we are and what orbit that will put us in. We came into a little bit of an elliptical orbit on our first mission, which was lower than we would like at the South Pole and higher than we would like at the North Pole. And so we want to get that perfectly circular at about 100 kilometers. So that's the biggest change. Obviously, the laser rangefinders, that was immediately fixed. Unfortunately, that was a quality miss on our part for a harness where we got out of configuration a little bit for a
Mm.
wiring harness. But we've got that resolved and tested, and everything's going well. So the goal, though, David, was to to fly essentially the same lander and do it over and over again, because every time you fly it, you learn about it and you can perfect it without redesigning a custom spacecraft every time you fly. So
Right.
we didn't want to go right from a Nova C lander, which takes about 130 kilograms to the surface of the moon. It's on the order of about 2,100 kilograms totally fully fueled. Um, we didn't want to go right to a heavy cargo lander after our first mission, obviously. We want to get some runtime on the systems on the core of Nova C so that we can perfect that before we upgrade the lander. And so that's coming down the road, the heavier cargo version. But right now, we're going to fly um, 4 missions now with Nova C.
You mentioned that you mentioned the altimeter, but there was also what you didn't mention in there is that there was a lot of behind the scenes ingenuity and sort of thinking of plan B, plan C, plan D to kind of make that landing possible. And I wonder, and I mean I suspect I know the answer to this, but when you look at the nature of rocket reusability, for instance, that has certainly there's been mishaps, but generally speaking, these rockets go up and they come down. It's almost become humdrum now in terms of the industry. Whereas a couple of years ago, it was just mind blowing to see a Falcon 9 land on the launch pad or out at sea. And now it's just something that the public has come to expect. And I wonder if that's sort of the goal here with Intuitive Machines as well, is to kind of get to this point where going back and forth to the moon, almost this like FedEx service that you're endeavoring to set up, has become just sort of expected, almost the way it was back in the 1960s and 70s, just in a much different kind of way, to the point of infrastructure building. And then what's next? I think is the follow-up question to that.
Yeah, I think what we have to do. The geopolitical tensions between the US and China are such that we're in a space race. And I think that once the US economy is ignited in terms of demonstrating how innovative it can be and how you can drive the cost of flying to and landing on the moon down That's just incredibly challenging and it's risky. And so it's only by doing a regular cadence of missions, time after time after time, and driving towards making it routine. That's where you're learning every time. You're fixing operational challenges along the way. You're fixing engineering systems and repairing them and making them more robust every time. And your learning curve, like I said, is very steep. And so let's keep flying. Let's keep flying over and over and over again and learn from our experiences and build more robust systems. And I think when it becomes mundane, I think we've achieved something, and we've done it at a price point. I think I had one investor in the talk to me about investing in a company, and he was like, "Steve, doesn't it take like $1 trillion to go to the moon?" And we were chartered with going to the moon fixed price for less than $100 million. Like that's a massive challenge, and
Sure.
we didn't quite make it at the $100 million mark. We spent a little bit more than that, maybe 10-20% more. But what we did was we showed where the floor is. Well, how cheaply you can actually do it if you put your mind to it. And now we're going to build back in robustness to fly more complex missions, heavier cargo, things like that.
You mentioned China, and I'm glad you did because I was going to get to this later on in the forum. But since you mentioned it, I've spoken to a couple different people within the Chinese space sector, both the commercial side and the state side, and they're obviously paying a lot of attention to what happens here commercially. A lot of attention to intuitive machines, a lot of attention to SpaceX, Blue Origin, the like. One of their sort of counterpoints is that the U.S. space program is not what it was with Apollo. And in other words, this is not sort of the same sort of state initiative that propelled American astronauts to the moon in '69. Um, and it almost seems like we have this kind of competing duality of systems here in terms of that, like state sponsored, funded, and it's not saying that they don't have commercial or sort of quasi private entities that are pushing, efforts in lower Earth orbit and even in the lunar surface. But generally speaking, that's a state effort. Whereas the United States, Artemis, it is an umbrella organization or umbrella a network of different countries, but it's a heavy lean on the private sector in a way that's just very different now. And I kind of wonder long term in terms of what that looks like as you have like these two competing systems that are vying for some of the same real estate.
Yeah, I think fundamentally different space programs, the state sponsored programs of the Apollo and where China is today, where a country, a sovereign government, will build a monolithic program pretty much by itself to compete in a space race back in the Apollo days. Well, then we moved to the days of International Space Station, where different governments built modules that connected, but weren't really fully integrated. They were connected at an interface that was clearly defined, right? So it was really major sovereign governments playing to cooperate in space and the International Space Station. Well, then the advent of commercial space grew with commercial cargo and commercial crew resupply of the International Space Station, where the burden of going to space, accessing the space station, and delivering cargo and crew became looking for it to drive the price down. They looked for the innovation of the commercial sector. Well, now as we go forward, for the first time in history, we go forward into space with space exploration to return to the moon, with the commercial sector carrying that burden and leading the way for scientific and discovery reasons, for logistics and cargo reasons, for operating infrastructure as a service. That is a challenge, but I think that's an exciting time for us. And I think in order to get true innovation, really, you look at the way goods and services are acquired now. The government, NASA in particular, has shifted its acquisition model to uh, buy the infrastructure from commercial sector and prove out that the U.S. Economy can deliver lunar infrastructure commercially. And I don't believe that's something that China's doing. I think that's something where the United States leads the way, and that is the true competitive advantage of the United States once we get going. We might look like we're moving slowly and making baby steps, but I'm telling you, we're changing the landscape quickly with every mission that goes to the moon. Now, we know Artemis program as a whole, when you put crew and introduce astronauts into it, the programs get complex and schedules get stressed and budgets get stressed and it moves to the right. So we have to keep filling in with commercial sector flights for engineering and science and logistics and all those things. And if we keep flying, it's okay that the crew slips to the right a little bit. We'll keep learning about the moon. And I think that's the way you'll see potentially a restructuring of Artemis, maybe post election, when the real budget realities set in and we figure out where the first missions to the moon are actually going to end up. And then it'll be in essential that the commercial sector is prepared to respond, to fill in along the way while we develop the crude systems.
I'm glad you mentioned all those points. I want to ask one more question about sort of the structure of IM1, IM2, and then we'll sort of pivot to sort of where some of these recent contracts that we've talked about. But you're a NASA guy, right? You worked at the Johnson Space Center, so the Intuitive Machines has been in your bailiwick for the last decade, sure. But I wonder, in terms of some of the innovations and the change in practices that you saw with Project Morpheus back in the NASA days. This is a methane powered potential lander for another celestial body, and some of the successes and the failures that you had, but also in terms of like the structure of supply chains and 3D printing parts and the nature of doing these things, not on the cheap, but certainly a lot more cost effective than had been the reputation. And you carry that forward. So like that innovation happened actually within a public sector environment. And I'm wondering like how you carry that forward into everything you're doing now, because a lot of the guys that you have on your team now were also on Project
Yes.
Morpheus.
Yes, I'll tell you, we learned a lot in that Project Morpheus or Project M. Put a walking robot on the moon in 1,000 days was the challenge that I gave to the team. And we never did it. We put a walking robot on the International Space Station, and we built a lander, liquid oxygen, liquid methane lander for Earth that we flew some 37 times on Earth and avoided hazards, simulated hazards that would be on the moon. So we learned about that, and we did that with a mind towards use what you know in terms of human spaceflight engineering, but streamline it and get rid of the things that are just maybe bureaucracy or imposed constraints that aren't really contributing to the accomplishment of the goal. And trying to find that lean, affordable way of doing a project was what that experiment was inside the government. And it lit in us an entrepreneurial spirit that we carried forward, right? And so the way we do engineering, you have subject matter experts and leaders who are technical, who know their business, who know how it's supposed to be done, and then they can teach other engineers that are, say, early career. We mix subject matter experts with master level machinists, with early career engineers, and have this recipe for a workforce that is incredibly capable, instilled with the purpose of a mission or mission driven, right? You put that all together, and that's what's building this company. That's where Intuitive Machines is gaining its chops, if you will, right? So it's how we're successful, and you know innovate. We're doing something impossible, David, that's never been done before. So you can't do it like everybody's done it before. You have to do it differently. And you hit a roadblock, you innovate around it and find a solution and go forward in a different way. And always challenging ourselves to think about the problem differently when you hit a snag, and never give in and keep trying and persist. That's kind of the recipe that we took out of our experience with Project M and built a company around.
Okay. I'm going to pivot now to this potential up to $4.82 billion NASA contract that Intuitive Machines recently scored. But before I do, I just want to address everyone in the chat. If you have any questions, make sure to dump them in. We're going to go for probably another about 20 minutes or so, and then I can take some of your questions that will be funneled through to me by my colleague Dan. So send them over, and we can make this sort of more interactive discussion. Before I pivot actually to that nearly $5 billion contract, are there any updates and any little tidbits that you'd want to share with us with regard to IM2 that's not out there in the public ether as of yet?
We've gotten through nothing really that's not out there, but one of the successes is we had is we've got the vehicle put together, and we did the engine firing on the vehicle. We last quarter earnings, I reported that we did the qualification of the engine. Well, that was completed, but then we mounted on the vehicle, and we lit the engine on Addy, Athena, or Addy's the nickname this time,
Hmm.
in an enclosure purged with nitrogen, and we lit that engine 6 times, burned it 30 to 40 seconds each time, got the mixture ratio just right, all the motor valves, the throttle valves dialed in, and so that is a highly risky test, and it's we're through it successfully, and so that is a major milestone for us. I'm proud to say we made it through that test um, very nicely with a great understanding of how the system will perform as an integrated system. So kudos to the team for pulling that off.
I imagine Rob Moorhead is still not quite sleeping at night yet until that second.
I don't think he sleeps much any night. He's always thinking about valves and thrusters and engines and
For those
propellant. So
on the
that's
call,
great.
Rob Moore has a propulsion lead, Intuitive Machines, and nicknamed the Rocket Whisperer, I think, by your team.
Yeah.
Okay, so I want to pivot to this $4.82 billion contract. Explain to me what's involved in here, if you can, and how this really fits into NASA's Near Space Network, which, if I'm correct, will extend communications beyond Earth about 4 times the distance between Earth and the moon, so about 1 million miles out. And so, when I see something like that, I think, okay, NASA's thinking bigger picture here. Is there a wherewithal from the legislative side? Is there a wherewithal from the private sector side? And well, let's start there. Talk to me about this contract that you all just netted.
Yeah. So the contract we were just awarded, uh, the total contract value not to exceed price is or value is $4.82 billion over 10 years, which is incredible. I don't know if all those services will be purchased or not, but it allows for a myriad of surfaces of services. The Near Space Network Services contract line item was 2.2, and what it was for the data relay satellite constellation to deploy that around the moon, and develop that communication to and from the surface of the moon and to and from those relay satellites to the ground, and also provide the position, the navigation, and the timing services as part of that constellation. So it's communications and navigation. So you can bring back the essential data you need from the moon, from the lunar surface, to operate systems autonomously and to support crewed missions to the moon. So it's really important that it's augmenting what NASA provides through space communications and navigation services already through via the Deep Space Network and the ground network that supports that. So the Deep Space Network, brings those beautiful images back from the Hubble telescope and the James Webb telescope, and does all the communications with our deep space probes and Mars probes. Well, it's busy, and it needs they need more capacity. And so, in the spirit of one mission, one network, one team, Intuitive Machines won a piece of that called the Near Space Network Services contract, which is we are now part of the bigger scheme for how NASA and the government provides deep space communications out to the moon and beyond the moon. If you recall, Uh, I think what set us up to be awarded that award was the fact that in our mission one, we built our own or constructed our own ground network around the world with
Yeah.
8 different dishes in 6 different countries, augmented by another company that provided other
Explain to me
dishes.
why you did that. Why? Because I think this is fascinating. Why you did this?
Well, I think it was a miscommunication between ourselves and NASA, where we heard that NASA said, "Go try to fly to the moon, bring us back our science data. Here's your payloads, and you're not allowed to use the deep space network." Okay, well, how do you solve that intractable problem? Well, you go form your own ground-based network to communicate to the moon. And what NASA really meant was, no, you have to pay additional to use the deep space network. Well, we didn't think we could use it, so we went around the world and contracted with the radio astronomy dishes around the world, the big ones, 18 to 64 meters, and put them on contract so that when the moon was in view, they would be looking for our mission. And they're not doing radio astronomy when the moon's in view because of the noise it creates. So we built this ground network. And so we had a commercial capability for the first time and demonstrated it at lunar distance with our mission one. So now NASA says maybe commercial sector can handle the communications piece. Let's try this contract, model it much like the CLIPS Awards, and see if we can't get a company to do the commercial network and add to our capabilities and be part of that integrated team. And that's kind of how it came about, and that's why we're in a position we are today. With that contract, we will be deploying a constellation of satellites around the moon. First satellite will go up on mission 3, which is late 25, early 26, depending when the satellite's ready. I think I might hold that mission for that satellite, which is really important. We'll see. I haven't decided on that yet. And then every next mission, we bring up 2 satellites, 2 more satellites. And so we'll have that deployed and offering services back to NASA and other government groups as soon as it's in place.
Talk to me. First of all, that's a one of the biggest infrastructure building miscommunications I think I've ever heard. But uh, but it's remarkable, sort of what's transpired out of that. But talk to me a little bit about that 4K data link that I keep hearing about here, because this to me is really interesting in terms of perspective, about what the notion of not only all that data that could come back, but the notion of 4K video in and around the lunar surface and deep space. These capacities are growing, obviously, and we have some of that already. And the imagery clearly with the James Webb Space Telescope has been just paradigm shifting in terms of just general humdrum conversation you hear in coffee shops and bars and that sort of thing. But I wonder what that could lead to.
Yeah, I think, back in the days of Apollo where we got those black and white fuzzy images back, um,
That's
but this
exactly my
is
point. That
incredible.
was that was video, right? That was yeah.
That was, incredible. But, our appetite for data and information and, real time, we needs we meet means we need a bigger trunk line to Earth. If we want to really show the American people and the world what the lunar environment is really like and what it is to live and work on the moon, we have to show high resolution videos, color images, and color videos of people living and working in space. And so I think this is essential to kind of push the envelope forward to improve the quality and quantity of the imagery and video that can come back from uh, all the operations that'll go on the moon. And I think it'll help us keep the program sold going forward if you can bring back a richer data set of the moon, of geological features, of prospecting information for where rare materials might be,
Starts just to seem
of
more real then, right?
yeah, it makes it tangible again, like, and not just what's in a sci-fi movie. It's real. So I'm really excited about it. It's a very uh, intense couple of years here to put this together and build out this capability, but it'll be a wonderful addition to our infrastructure for the United States to be able to leverage to really keep the Artemis program moving forward.
The corollary with the Apollo 11 video feed is really an interesting one because that, I mean, it was you speak to, I mean, this is the most obvious statement in the world, but you speak to everybody who's within the space industry, and that was that seminal moment, and even for people who weren't. But it's such a different time now too, from 1969 to 2024. And I mean, yes, we have a lot of the sort of same or similar, political dynamics, perhaps, in terms of the polarization and all these other things. But it struck me that, with Apollo 11, you had a captive audience, right? You're only getting like one of three or four broadcast networks, or three broadcast networks in the United States, or globally. You had this was a state program, right? In terms of, these are American astronauts that they're going up there, so it was a galvanizing capacity with that. And then you had the sort of a paradigm that just very different in terms of how people consume information now, and sort of like the bubbles that we can all find ourselves in terms of our own like pet interests. And I wonder, from your perspective as the lead of a commercial entity that's doing some of the same types of endeavors, in a much more difficult type of terrain, albeit unmanned at this point. um, how do you drum up that same sort of excitement, or how do you galvanize people who may question, did we just land on the moon, or did a private company just do that, and can I still get behind that in the same way? And maybe because this had been done in 72, there's not that sort of same sense of just this complete marvel of the pioneering nature of this, when truly it is groundbreaking. That just seems like a barrier that you're up against, that you have to kind of figure out how to cross.
Well, maybe I think there's just great excitement about flying in space, and um, it lights people's imagination. And I think the outpouring that we received from Mission One worldwide was absolutely incredible.
Mhm.
I'll tell you, here's a metric we looked at over a 30-day period around our mission to the moon. There was 198 billion touches on the content that was produced as a result of Mission One. That's population multiple times over looking at and curious in and tuning into what was going on with the mission.
Mm.
That is more in a single day than the Super Bowl. So the world is really interested in this, and I think if we can bring that 4K video to our social media, our phones, it'll go viral around the world, and I think it just brings more people into the conversation about the importance of space exploration, and we can ignite more of youngsters' imaginations with dream about space and aim high and do great things, and maybe get them excited about education and moving into engineering, mathematics, technology, those kinds of things. So
Yeah.
I just think it's an opportunity. I really don't see it as a barrier. I just so many people are interested in this, just fascinated by what we're trying to do and what all of us in this or in this space sector are trying to do.
Is it just a technical question? Excuse me, with regard to some of these data relay satellites, does that mean that some of these future crafts are not going to have that sort of breath holding moment as the craft dips but behind the far side of the moon there, and sort of lose radio comms? Is that sort of the expectation? Because I certainly know, though, all of you guys were holding your breaths collectively as Odie came around the backside of the moon there.
Yeah, I think, well, landing on the moon is a totally different animal than flying in orbit around the moon. So we go to these frozen polar orbits, they call them, and takes very little energy to to stay in that orbit and maintain that orbit. So once you're delivered there, once we deliver it there, it'll stay for a while, and we'll go down to a skeleton crew to monitor that satellite until we bring a bunch of data down from it, or that constellation. But I think, that once you're in orbit, it's stable, but that powered descent, when you go all the way to the surface, you've got to take out about 3,600 meters a second down to the surface, and that's a nail biter every time. So
I
landing on the moon
wonder
with
if
a
you I wonder if you could kind of explain that bit a little bit more, because I don't know that at least the layman audience kind of understands that you almost have to drive this craft into the lunar surface. It's not like an airplane where you just sort of like throw the flaps up and you touch down here. I mean, it truly is this power descent in which you're ratcheting the throttle back, which I know your team had been working on, sort of ignition timings and propellant ratios and the configurations of how those things actually looked. I don't know how many different iterations that your team went through there. It was in the dozens, I believe. But explain that process to me a little bit more, and then I'll also ask everyone in attendance. We're going to be taking audience questions probably the next 6-7 minutes. So if you have other questions, get them in now, and I'll try to get to as many as I can.
All right. So yeah, powered descent is you put all this energy into getting the lander outside of Earth's gravity well and into orbit around the moon, which is an incredible braking burn to slow down the capture in the gravity well of the moon. Well, now you're going around the moon at a certain velocity that all of that energy has to come out, and you have to slow down to zero, to a stop at the end, or you crash, right? So, how do you bleed off all that energy? Well, you turn the spacecraft around and you fire against the rotation of the orbit, and you brake and you fire for from about 100 kilometers or 85 kilometers altitude, and you fire the engine, and you fire it at 100% thrust for about 13 minutes, the longest 13 minutes that you can imagine. And you initiate that powered descent autonomously from the backside of the moon. You go into kicking off the powered descent while you can communicate with the vehicle, but it does it all by itself around the backside of the moon. And then down you come, and about a minute left to go, the vehicle pitches over and throttles down and throttles down as the propellant goes down in the tanks. We don't want full thrust anymore because you'll start to go up. So you throttle down to about 20% of throttle, which is getting an engine to run full speed and then having it throttle to 20% is not an easy thing to do. And you got to get those mixture ratios of the liquid oxygen, liquid methane just right as you're throttling down that profile. And then we get into a steady descent of about 1 meter per second. That's fairly slow. That's slower than walking speed. And you come down and you come down at 1 meter per second until you actually fly right into the surface at 1 meter per second. And when you do that, the IMU tells the main engine controller, I'm not descending. I'm not descending. And three times, every time the main engine throttles down a little bit more, throttles down a little bit more, three times it shuts itself off. And that's when the engine's done and you're down safely. So it's a very complicated sequence. Like you said, we've practiced and tuned over lots of time at our career at NASA and here at Intuitive Machines. And um, we got landed a little bit harder on the first mission because we didn't have those laser altimeters to tell us how far we were. And so we weren't all the way throttled down before we contacted the surface, and then we had a broken landing gear. So
Yeah.
that was the case there. But we'll get it. We'll get it the next time.
All right. Well, before we go to questions, I really have just one more big picture question in terms of, where Intuitive Machines expectations are, not this quarter, not next quarter, not this year, not next year, but if we're looking at 5-year plans, where do you see Intuitive Machines going? And, right now, Intuitive Machines' predominant source of revenue comes from the federal government. And given what we've seen in the past, or the fickle nature of Congress and, different legislative priorities and funding capacities or not, and, who's atop the agency, who's not, I wonder, and I know Intuitive Machines has done a good job in terms of diversifying payloads, but do you envision a moment in which, absent federal contracts down the road, this is, or maybe not absent, but something that could sort of weather your company through those changes in priorities, should they come 5 years out, 7 years out, as we go forward?
Well, what we enjoy today is bipartisan support for the space program, and in particular, a drive towards sustained human presence on the moon. The moon is of strategic interest to the United States, and therefore, the United States is spending money to return humans to the moon. And, those programs are, like I said, under budgetary pressure and schedule pressure always, as NASA tries to do these complex things. And so for Intuitive Machines, providing the delivery services and bringing up heavier and heavier cargo, putting satellites around the moon, delivering heavier and heavier cargo and pieces of infrastructure to the surface is what we do. And we'll operate that infrastructure using the communications and navigation services that we put in place with this constellation of satellites, and bring that back down to our ground network, the lunar data network on the ground, and be able to operate, move to, transport, operate, and navigate. So imagine where you want to put things with precision. You want to do path planning or landing site assessments. All that data will come out of that data relay network. And I think ultimately, we're going to add to that constellation a surveyor or prospector to get greater imagery and data about the moon, to have what may be possibly the largest data set of the moon, that will inform us where to go in the future to get to rare materials, water, or do landing sites for Artemis or whoever's going there, and provide that as a service, with
Hmm.
the ultimate goal of how do you bring these materials back from the moon? Another critical piece of the infrastructure that has to be added is the return from the moon. Um, and how do you bring that industrial capability back? And so those are the kinds of things that Intuitive Machines is working on, and that's where we're headed, to be that infrastructure provider for cislunar space to help and grow the lunar economy like it needs to grow. I think we'll always do that in partnership with the government. The moon is of strategic interest, as I stated, and I think that always the government will be involved, no matter which government. I do see the commercial sector learning about payload development and now fielding payloads more than when we started in 2018. And so the commercial sector of the business will grow. About 20% of the business today. We see that growing over the next 5 years to 40 or 50% of the business. That's kind of
Right.
how I see things over the next 5 years.
Right. All right, so I want to go to audience questions now. I'm going to start with one of the journalists in attendance. This is Morgan McFall Johnson. She says, "Hi, Steve. My name is Morgan McFall Johnson. I'm a reporter at Business Insider. What is the U.S. commercial space industry getting wrong, or is there anything that you think needs to change?" I think it's sort of oriented around what obstacles that might be in your path, either from an approach, or you can even relate this maybe to the regulatory perspective, or things that are happening elsewhere.
Yeah. I think, we are seeing change. It's easy to be negative. I do think what's of strategic importance to the United States and the world is heavy lift. And in order to have a sustained economy around the moon, I think we need a heavy lift um, launch vehicle. There's several in development. There's government-led SLS. There's the uh, Starship by SpaceX and New Glenn by Blue Origin. And you know, when are those going to be delivered? At what pace are those going to be delivered? At what cost? And in order to move the lunar economy forward, sooner would be better. But if we're moving, those rockets are all moving to the right. We see some success with Starship, but there's a long way to go yet, um, in developing that system capable to go all the way to the moon, or even out to Mars. And so How do we make that more affordable? How do we get that delivered sooner? I think is a big challenge for the world and for us.
Right. The next question is from Human Te Mesebipor. I'm hoping I'm getting that correct. That question orients more around sort of how you kind of struck that balance between purchasing COTS components and in-house development. And it's like I think one of the questions, if I scroll a little bit further down, they're asking for sort of any specific anecdotes that kind of come to mind in terms of those aha moments of which when you thought you can go at it and get it yourself or build it yourself.
Yeah, I think the supply chain is something um, that was stressed for a number of reasons. One is we're starting with a number of missions to the moon by vendors in the CLIPS, Commercial Lunar Payload Service vendor pool, that all wanted to go buy components for their lunar landers to fly their missions to the moon. The supply chain wasn't built to fly to the moon. There was no business flying to the moon. The business was in other aspects of space, low Earth orbit, geosynchronous orbit. So, for example, we went out to buy cryogenic valves for our LOX methane propulsion system, and cryogenic valves don't last 8 days in space without leaking. They last what, a few minutes for an upper stage. That's it. So when we went to buy valves, the motor valves that control the feed of propellants into our out of our tank to the engine, the feed line, those valves leaked out of spec. So we had to take those apart, reinvent them, replace seals, rebuild them, and essentially create our own valve. And so there's 10 of those motor valves on each vehicle. They're the
Mm,
throttle valves, the feed line valves, et cetera. And we've had to go into the valve business to make valves because we couldn't get them in the supply chain. It's not like I wanted to vertically integrate because that's expensive.
right.
It takes capital investment, but out of the need,
It's expensive front end, but long term.
expensive front end, you save money in the downstream, but we're trying to go fixed price. So if we could buy it and move quick, we couldn't. Another one was thrusters, attitude control thrusters. We have
Mm.
helium thrusters, and we couldn't get those purchased in the supply chain without the leakage problem. So we built our own attitude control thrusters for the first mission, and the second mission, and the third mission. So we only vertically integrated out of necessity, right? And now we build about 85% of the complete lunar lander ourselves.
I
As
remember I
a
remember during IM-1 though, there was that question of whether there was enough helium left in the tanks to make it to the surface. That was there's I guess that's a question that I have in terms, I mean, it does seem like, I mean, this might be a mass question or just a sheer volume, but the margins are so slim on these things. And part of that I imagine has to do with just the nature of getting in those fixed costs and profitability and just the nature of making all these things work. But it does seem like running on a razor's edge at times.
Yeah, it's not like you're trying um, to eke every bit of margin out of it so that you can make money. It's that going to the moon is difficult. The physics are very hard, and so what you have to do is you have to build the lightest craft you possibly can, and you carry only so much reserve in your propellant margins,
Yeah.
right? And so if anything goes wrong, you have a limited set of commodities on board or consumables. In the case of the helium, we had some excursions. If you remember early on in the flight, when we couldn't get a lock from our star tracker on the sun
I remember,
pointing to
yeah.
charge the batteries, we
Yeah.
used an awful lot of helium
Tumbling.
as we're tumbling to kind of correct that.
Mhm.
And that helium was not in our budget. And so when we got to the moon itself, um, were we going to have enough helium in the tank to do that final roll position to align the solar arrays with the sun? And that was the analysis we were doing, and that's what we were on a conservation program during the mission to conserve helium. Um,
Mhm.
and so that was the challenge for us. And we got thank goodness, and the tanks had enough pressure in them to get us all the way to the ground safely in the end. But you're right, the margins are razor thin. The
Yeah, I
mass
mean,
margin for structure and propellants and everything, and
there's this
that's the
old
nature
old
of building spacecraft.
there's this old redundancy sort of saying in the military that two is one and one is none, and that just not it's I imagine that's hard to build into in practice, and when you're concerned about just that sheer mass question, and and all the other considerations that go into it. One other question from the audience here. You sort of touched on this earlier, but this is from Josh Gregory, who says, will Intuitive Machines only build infrastructure for NASA, or will they eventually be able to partner with ESA and other similar agencies in terms of the kind of construction and infrastructure building that might lead to the well, the beginnings of the lunar economy?
Yeah, we definitely want to partner with international space agencies and commercial companies internationally. We were just
In
over in
Artemis, I would imagine. Yeah.
yeah, we were just over in Milan um, at the big international conference there, and speaking to the international space agencies about their aspirations for flying their equipment to the moon, their payloads to the moon, our ability to fly certain things, and everyone was interested in talking about how do we do this together, and I'm really open to that, because it will take all of us to collectively open a lunar economy. It isn't one company wins. It's collectively we're building an ecosystem of of companies that want to advance the lunar economy and governments that want to advance the lunar economy. And so playing in that arena, I see international business growing. I think we're up to 9 different international payloads now in our space systems. So it's good. I really it takes a lot of travel, but it's fun to talk to everybody and hear what their plans are and see how we fit together to fly together.
Right. All right. This next question is from Pal Molnar, and the question essentially is, when does Intuitive Machines plan, or if does it plan to venture into the field of human space flights?
Aha, very good question. In fact, we're already involved in human space flight. We were successful in a contract that you didn't mention today, David, and that was the Lunar Terrain Vehicle.
That's
So the NASA Lunar Terrain Vehicle contract was let to 3 contractors. Intuitive Machines was one of them, with our Team Moon Racer, which is Intuitive Machines, Boeing, Northrop Grumman, Roush, AVL, and Michelin. And we're building, designing right now in this first phase of the contract the a lunar rover, unpressurized for astronauts, that actually will operate autonomously for 5 to 7 months a year and operate with crew another part of the year. And so it's a commercial rover that's the size of about a F-150 pickup truck that should operate and explore the lunar surface when the astronauts are not there. And then NASA will fly payloads on it and fly astronauts to it. And the astronauts will take long excursions around the surface to explore that region of the moon. So it's a very exciting program, and to be part of something like that is just incredible. Something directly involved to transporting humans for Intuitive Machines to win that was phenomenal, and we're competing now on the follow-on to actually deliver it to the surface.
The next couple questions are actually oriented on that lunar rover. I wonder if there's an update that you can give us about this that might not be out there in the ether as of yet. No pressure though, if not.
Well, the lunar terrain vehicle was very interesting. We had the astronauts come out. Some of our group of our astronaut friends came out to do fit checks and climb all over it to see how it how it felt. And we were fortunate enough to have Charlie Duke and Harrison Schmidt,
Oh
people
wow.
who've actually walked on the moon and drove the rover in the past, give us feedback, and that was incredible. They actually signed it, and we put a little piece of plexiglass over the signature so we didn't smudge it, and a little frame but they actually evaluated and gave us a thumbs up. We just delivered our mock-up version to NASA for the human in the loop testing, where the NASA astronauts will climb all over it and look at it and give us an evaluation of how it performed, from a human systems standpoint. So very exciting time, and um, I think we're very proud of that vehicle that we've developed to this point.
Yeah, I mean, just for those in attendance, Charlie Duke is. I actually spoke with him a couple months ago. He's a really fascinating guy. But this is the man who was not only on the lunar surface, but it was that voice that you heard in Mission Control when Neil Armstrong radio back and said, you got a bunch of guys breathing again, we're about to turn blue, during that Apollo 11 landing in '69. We've only got about 2 more minutes here, and I guess one of a good sum up question that I think I have is maybe precisely the nature of the methane powered engine that Odie had, and the decision to make that methane powered, which is it can be a harder fuel to ignite in space. There's some groundbreaking technology that was done there, but I wonder, like, in the back of your mind, given the focus on Mars, given the nature of the methane rich environment there, like where does that play into your long-term thinking?
Well, the way we looked at it when we made the decision to go to LOX and methane cryogenic engine was a number of reasons, but we said, let's build the most robust engine we can for exploration of the solar system. And to quote Dr. Crane, who's a partner in the company, and he says, I want to build the Conestoga wagon of engines for the solar system. And so we have a brilliant liquid oxygen, liquid methane engine um, that can take varying purities of oxygen and methane, and burn it consistently and reliably with no rotating machinery. Once it's developed and once it's set, it'll run and run and run, and it's a very robust engine. So we used advanced manufacturing techniques, a lot of long nights and you know, sweat and dirt under our fingernails to get it working right. But it's a very high performing engine that can reliably move us out into the solar system and hopefully take advantage someday of those in situ resources that we find on the moon and on Mars. And so that was definitely in our thinking. But a more simple version that's maybe not as glamorous is that we could work around it in shirt sleeves. Like there's no toxicity. We just could work around it. And so you want to fire the engine, you stand away from the blast area and you fire the engine.
Yeah.
There's not carcinogenic chemicals or anything like that. And so it was really convenient for us to go with friendly commodities also. So a combination of decisions, but yeah, Conestoga wagon of the solar system. Think about that.
All right. Well, that is a good place to leave it. That wraps up our very special Space News Forum with Steve Altemus, who's the president, CEO, and co-founder of Intuitive Machines, who's gearing up for their second potential lunar landing sometime early next year. I also want to say thank you to our sponsor, Advanced Space, and we'll see a quick word from them. All right. Thank you again to Steve. Thank you again to the Intuitive Machines team that made this happen, and thank you everybody in attendance for what I hope you found to be an enlightening, interesting, and energetic conversation, and we wish them well in their future endeavors.
Thank
Thanks
you,
again.
David.